When the sun reaches its zenith at midday, we experience intense brightness. As the hours pass, the light weakens until nightfall, enveloping us in pitch-black darkness. Despite the multitude of cosmic light sources adorning the firmament, the night sky appears dark, prompting the question of why the universe seems gloomy during nighttime. The ERS paradox comes into focus, questioning why the night sky, with its countless stars, isn't as brilliantly bright as the sun. The paradox revolves around the assumption of an infinitely large and uniformly distributed universe. Our planet takes 24 hours to complete one rotation on its axis, creating the impression of the sun moving across the sky during the day. Once the sun sets, we lose our natural light source, and the night sky, despite its sparkling formations, remains dark. The ERS paradox challenges the idea that an infinitely extended universe with a uniform star distribution should result in a brightly lit night sky. Johann Kepler raised suspicions about this in the 17th century, initiating a cosmic enigma that puzzled the scientific community. The ERS paradox is based on cosmological principles, assuming a homogeneous and isotropic universe where observations remain consistent from any point of view. This implies that in an infinitely extended universe, starlight from every direction should reach Earth, making the night sky as bright as a star's surface. However, the reality observed in the night sky contradicts this assumption. Heinrich Wilhelm Olbers proposed a solution, suggesting that the gases between stars absorb emitted light, explaining the darkness of space. However, this explanation was flawed, as the absorbed light would eventually heat up the gas, making it shine brightly. The mistake was later recognized, and it became evident that the distribution of stars in space is not uniform. Stars cluster in galaxies, and galaxies form large clusters, challenging the initial assumptions. Contrary to the original assumption of an infinite void beyond our galaxy, it was discovered in the early 20th century that distant galaxies house billions of stars. While the night sky may not be as bright as initially expected, the average distance between Earth and celestial bodies is immense. This galactic average, quantified at 10 to the 23rd power, or 100 trillion light-years, means that starlight hasn't had enough time to cover this enormous distance. Even though the universe is estimated to be about 13.8 billion years old, the observable part is relatively small. The finite nature of stars adds another layer to the cosmic darkness. Stars have a limited lifespan, and their nuclear reactions last for a relatively short time. So the night sky is not as dark as it appears, considering the cosmic microwave background radiation, a remnant of the Big Bang, and the continuing expansion of the universe. The cosmic microwave background radiation, once brightly illuminating the universe, has significantly decreased in intensity over time. While we perceive only a fraction of the existing light spectrum, the spectrum itself includes infrared and microwave ranges that we cannot detect with our human eyes. Experts estimate that visible bionic matter constitutes only 4.9% of the total matter in the universe, with dark energy and dark matter making up the rest. The expansion of the universe contributes to the perception of a dark night sky. The Big Bang, occurring approximately 13.8 billion years ago, initiated an ongoing expansion, causing all structures in the universe to move away from their original points. As cosmic structures, including stars, move further apart, the darkness between them intensifies, contributing to the deep black appearance of the night sky. The constant expansion also leads to a reduced radiance of the cosmic background radiation, further contributing to the darkness we observe. Unbelievable developments are unfolding on the Moon, revealing what NASA purportedly concealed. Following the failure of the Russian Lunar 25 mission, India's Chandrayaan-3 has made a mysterious discovery. This mission signifies India's entry into the Premier League of spacefaring nations. The successful landing of Chandrayaan-3 on the challenging south pole of the Moon has catapulted India into space history. India's achievement on the lunar surface drew widespread joy, especially considering the setback with Chandrayaan-2 in 2019. Despite initial trepidation after the Russian Lunar 25 mission mishap, Chandrayaan-3, with improvements, embarked on a mission to the Moon's south pole. The difficulty of this endeavor was underscored by the rugged and harsh terrain, making it a significant feat. The fully automatic landing system employed by the Indians demonstrated high-tech prowess, outshining the manual control challenges faced by the experienced specialists at NASA. Chandrayaan-3, reaching lunar orbit, showcased its fully automatic capabilities during the landing approach. Equipped with high-tech cameras and real-time navigation systems, it achieved a soft landing on the lunar surface at the South Pole on August 23, 2023. This historic moment marked India as the first nation to land a man-made object at the South Pole, initiating immediate operations post-landing. Computer simulations indicate that Venus was once a watery world with an atmosphere and possibly life. Today, Venus has a dense carbon dioxide atmosphere, resulting in extreme temperatures of up to 460 degrees Celsius on the surface due to the greenhouse effect. The presence of phosphine in Venus' atmosphere, discovered in 2020, hints at potential life forms, as phosphine is typically associated with biological processes on Earth. The Chandrayaan-3 mission involves two distinct satellites: Pragyan, a small rover equipped with a laser to analyze lunar regolith, and Vikram, a lander serving as the ground and temperature measuring unit. Pragyan's laser analysis heats up specific spots on the moon's surface, providing valuable data on lunar rocks. The rover, moving at a speed of around 1 centimeter/second, navigates with a specialized wheel mechanism to overcome lunar terrain challenges. Initial soil analysis revealed more organic minerals in lunar dust than previously assumed. Vikram, on the other hand, measures ground temperatures and drills into the lunar surface. The primary objective is to detect ice deposits, crucial for potential lunar colonization. The lunar South Pole's significance lies in its presumed abundance of water, essential for sustaining human settlements. Chandrayaan-3's mission has unveiled unexpected information about lunar temperatures, suggesting that water ice might be deeper below the surface than initially thought. Water resources on the moon, particularly at the lunar poles, are crucial for future lunar habitats. NASA's Artemis missions, planning to establish a human presence on the moon, emphasize the need for local water resources. Chandrayaan-3's findings add a layer of complexity, indicating potential challenges in accessing water ice due to the thick regolith moon dust serving as insulation. However, this could also offer protection for future lunar houses, utilizing the lunar soil to shield against extreme temperatures. While Chandrayaan-3 has provided invaluable insights, it is not the sole player in lunar exploration. China's Chang'e 5 rover has explored the far side of the moon, discovering water trapped in tiny glass particles within lunar dust. This unexpected find opens new possibilities for extracting water from the moon, with lunar settlers potentially heating moon dust to access water resources. In conclusion, India's Chandrayaan-3 mission has not only made a significant mark in space history, but has also contributed valuable data to lunar exploration. The quest for water resources on the moon continues, with unexpected discoveries reshaping our understanding of the lunar environment and its potential for human habitation. It appears that India has encountered a significant setback following the initial successes of Pragyan and Vikram. Unfortunately, after a period of silence and likely after the initial jubilation, India has had to accept the untimely loss of the probes. To comprehend the drama surrounding these two probes, it's essential to understand the unique lunar day and night rhythm. Due to the moon's rotation speed, there are 14 days of light followed by 14 days of darkness on the moon, making lunar days extremely hot and nights extremely cold, especially at the South Pole, where temperatures can drop below -100 degrees Celsius. Given these extreme conditions, Vikram and Pragyan were put into sleep mode at the beginning of September 2023, as they wouldn't be able to function in complete darkness and freezing temperatures. The plan was for them to automatically wake up 14 days later, but unfortunately, they did not respond. This led to a period of unrest in India, and despite all attempts to reach the probes failing, the Indian Space Agency provided minimal information. Public statements only confirmed that Vikram and Pragyan could no longer be reached. This is undoubtedly tragic, but it's unlikely to deter India from future lunar missions, and there remains hope that Vikram and Pragyan might revive and continue their mission. In another surprising development, scientists have unearthed evidence of potential life on Venus, a discovery that the Soviets allegedly concealed until now. This revelation challenges our decades-long focus on Mars and redirects attention to Venus, the brightest planet in the sky. Despite its brightness, Venus had been overlooked, but recent revelations suggest that it could have been more Earth-like around 700 million years ago. The conditions required for life to develop, including carbon structures and metabolic processes based on oxygen and minerals, could have existed on Venus. The possibility of Venus undergoing a transformation similar to Earth's evolution adds intrigue to the search for life beyond our planet. Controversial claims by Dr. Leonid Sanomani in 2012 suggested that Soviet images from the Venera mission in the 1970s and 80s contained traces of extraterrestrial life on Venus, further fueling the mystery surrounding our neighboring planet. In summary, the lunar setback for India is a challenging chapter, but it's unlikely to halt the country's space ambitions. Meanwhile, the potential discovery of life on Venus opens new avenues for exploration and challenges our conventional understanding of habitable worlds in the solar system. In 1985, the Soviet Vega 2 became the first to provide an accurate profile of Venus's surface. While en route to Halley's Comet, Vega 2 released the Vega 1 landing capsule, marking another significant achievement. However, it couldn't replicate the success of the Venera mission. NASA's Magellan research probe, the last major Venus mission, reached the planet in 1995. After a 5-year journey, it extensively mapped large portions of Venus' surface using radar during over 15,000 orbits. The iconic images captured by Venera 13 and 14, both Soviet spacecraft in the 1980s, remain unparalleled in the history of space exploration. These images, representing the first color images of another planet's surface, featured high-resolution panoramic views. Despite the groundbreaking nature of these images, the Soviet Union initially kept the Venera mission data confidential, revealing only essential information for propaganda purposes during the space race. Venera 13, launched on October 30, 1981, consisted of a propulsion probe and an attached descent vehicle. The descent vehicle, a hermetically sealed pressure vessel, carried crucial instruments and electronics for various measurements. Weighing around 760 kilograms, the probe contained instruments for chemical analysis, isotopic measurements, sunlight spectrum monitoring, electrical discharge recording during descent, and an array of other tools. Notably, it housed a sophisticated panoramic camera system that endured the extreme conditions of Venus, including temperatures exceeding 400 degrees Celsius and high atmospheric pressure. Venera 13's descent on March 1, 1982, proceeded flawlessly, with the parachute opening at 47 kilometers altitude. The probe landed east of a plateau known as Food Regio, capturing a panoramic image and collecting a sample immediately after landing. Venera 13 exceeded expectations, transmitting an astonishing 127 minutes of data and conducting investigations during its brief surface time. The subsequent success of Venera 14 further enriched our understanding of Venus's surface. In a different realm of celestial exploration, the discovery of interstellar objects has challenged our understanding of the solar system. Oumuamua, detected in 2017, initially drew attention as the first interstellar object to enter our solar system. However, recent findings suggest that there could be hundreds or even billions of such objects yet to be recognized within our solar system. Oumuamua, with its elongated cigar-shaped structure, deviated from typical asteroid and comet orbits, exhibiting unusual acceleration. Researchers speculated on the possibility of advanced technology or propulsion systems beyond our understanding. While Oumuamua appeared to be made of materials typical for asteroids, its peculiar characteristics, including the lack of typical emissions, raised suspicions. Further investigations considered the reflection of solar radiation as a potential source of acceleration, suggesting the presence of technology, possibly a solar sail. Oumuamua's dark red to brownish color and its difficult observability due to low light emission intrigued scientists. Alarming discoveries extended to near-Earth objects, which displayed structural similarities to Oumuamua. If these objects also originate from interstellar space, it implies that the Earth is surrounded by potentially billions of unrecognized interstellar structures. These revelations underscore the vastness of our ignorance about space, revealing unexpected phenomena within our solar system and raising questions about the potential presence of interstellar objects around Earth. Discovered in 2005, the periodic comet marked as P/ stands for those comets that have regular visits to our solar system, traversing it along large elliptical orbits. Originating mainly from the Oort cloud in the distant reaches of space, these comets, attracted by the Sun, follow trajectories influenced by planetary gravitational forces. Some may experience perturbations, but ultimately, their destination remains the same: the Sun. As comets approach the Sun, they undergo a transformation, forming captivating tails and becoming celestial spectacles. Halley's Comet, a well-known periodic comet with a 76-year orbital period, is famous for its beautiful tails. Another notable periodic comet is C/2011 KP36, surpassing Halley's Comet in size, measuring almost 50 kilometers in diameter. On the non-periodic side, Comet Hale-Bopp, often referred to as Hale-Bopp, approximately 75 kilometers wide, gained global attention during its bright appearance in 1995. Among the colossal comets are C/2021 VQ94 and C/204 UN271, with diameters of nearly 100 kilometers and 160 kilometers respectively. These giants, discovered in 2002 and 2004, appeared in the outer solar system, with uncertainty about their future return. The Oort cloud, a theoretical structure proposed by Dutch astronomer Jan Oort in 1950, is believed to be a vast sphere housing billions of comets and potentially unknown objects. This hypothetical cloud likely consists of icy bodies and protoplanetary matter, remnants from the early stages of the solar system. Comets observed within the solar system probably originate from the Oort cloud, where gravitational forces, possibly triggered by passing stars, cause some chunks to break free and head toward the inner solar system, forming characteristic tails when heated by the Sun. Although the Oort cloud is challenging to explore due to its vast distance, the concept remains intriguing, providing insights into the origins of comets and celestial bodies in the solar system. Moving on to Trojan asteroids, these unique celestial bodies inhabit specific points in the orbits of planets known as Lagrange points, maintaining dynamic equilibrium between the gravitational forces of the Sun and the planets. Named after the French mathematician Joseph-Louis Lagrange, Trojan asteroids share orbits with larger planets, either preceding or following them. Jupiter, in particular, has a significant collection of these fascinating objects, named after famous Trojan warriors from mythology. Unlike traditional asteroids, Trojans are incredibly stable, posing no danger to Earth. Despite thousands of known Trojan asteroids, their exact number and composition remain partially understood. The upcoming Mesa Lucy probe, launched in 2021, aims to explore the most important Trojan asteroids in Jupiter's orbit, providing valuable insights into these intriguing celestial bodies. Shifting gears to space discoveries, the James Webb Space Telescope has become a revolutionary tool, capturing extremely low light levels and enabling us to see further into the past than ever before. This powerful telescope has recently identified an ancient structure hosting 3 quasars, which are intensely shining phenomena within galaxies and among the most massive structures in the universe. Quasars, active galactic nuclei surrounded by gas disks orbiting black holes, emit vast amounts of radiation. The James Webb Telescope's advanced technology allows it to observe even the faintest signals from these distant quasars, offering unprecedented details. The trio of quasars under scrutiny includes J0 313 plus 1806, existing 670 million years after the Big Bang, with a black hole 1.6 billion times more massive than our Sun. Another, J1007 plus 2115, discovered around 700 million years after the Big Bang, boasts a black hole 1.5 billion times more massive than our Sun. These observations promise groundbreaking insights into quasars' formation, their central supermassive black holes' masses, the number of stars in their galaxies, and detailed explorations of their host galaxies' composition. The James Webb Telescope's 4 main instruments, including the near-infrared camera NIRCam and near-infrared spectrograph NIRSpec, will contribute to these groundbreaking studies. In summary, our exploration of celestial phenomena, from comets and the Oort cloud to Trojan asteroids and quasars, continues to unveil the mysteries of our vast and dynamic universe. The third member of this group is J1342 plus 928, which existed 690 million years after the Big Bang. This galactic center possesses a mass 800 million times that of our Sun. When the James Webb Space Telescope delves into the depths of the universe, it essentially provides a glimpse into the past. The light emanating from these distant quasars commenced its journey when the universe was likely in its infancy, taking billions of years to reach us. Examining objects like the quasar trio allows us to witness them as they were long ago, not as they exist in the present. The current status and whereabouts of these galaxies, if they still exist, remain unknown. All three quasars existed when the universe was less than 800 million years old, presenting a unique opportunity for scientists to unravel insights into galaxy evolution and the early formation of supermassive black holes. In James Webb's imagery, the light from these remote objects appears red due to the redshift effect. As light travels greater distances, it shifts toward the red end of the spectrum. The visible light emitted by the early universe undergoes significant stretching, placing it in the infrared range. James Webb's design, specifically tailored to capture infrared light, makes it exceptionally fortunate for studying these distant quasars. These quasars, set to be scrutinized by scientists, not only rank among the most distant, but also the brightest. Forming around black holes with the highest known masses, these quasars exhibit remarkably high accretion rates, signifying substantial material falling into the black holes. The enormous matter intake fuels the quasars and their jets. Compared to our galaxy's center, which has a relatively benign black hole with minimal matter intake, the three galaxies under study exhibit massive energy release. The energy streams extend into vast waves within the host galaxies, influencing the formation of star masses in different regions. Such outflows of energy play a crucial role in galaxy evolution throughout the universe. In some instances, these powerful outflows may hinder or entirely halt star formation within the host galaxy. There's speculation that the impact of outflows from highly active galaxies extends beyond their boundaries, redistributing gases, dust, and elements over large distances within the universe. This redistribution potentially feeds other galaxies or triggers the formation of new galaxies elsewhere. The text then delves into the era of reionization, a critical period more than 13 billion years ago, when the universe transitioned from a hazy state to clarity. Quasars, known for their ability to emit vast amounts of radiation, are essential in understanding the galaxy's activity during this era. The research team aims to utilize quasars as background light sources to study the intervening gas between us and the quasar. This gas, observed through absorption lines in imaging spectroscopy, helps determine the gas ionization state and provides insights into the universe's transparency during the reionization era. The narrative concludes by highlighting James Webb's previous discoveries, including the detection of 6 galaxies that challenge conventional expectations due to their age and size. The telescope's analysis of exoplanets, particularly WASP-39 bits and planets in the TRAPPIST-1 system, showcases its capabilities in scrutinizing the atmospheres of distant planets. This marks a new era in space exploration, with the potential for groundbreaking revelations about the oldest and largest quasars and the search for Earth-like exoplanets. The narrative emphasizes the excitement surrounding the possibilities offered by the James Webb Space Telescope and unraveling the mysteries of our universe. Buzz Aldrin revealed an incident during the moon landing that he had kept silent about for over 40 years. According to Aldrin, during the entire landing approach in 1969, he observed a green light flying parallel to the landing capsule, carrying him and Armstrong. Aldrin mentioned in an interview that the light remained unidentified for decades, and while there were explanations suggesting natural phenomena like a piece of the rocket stage or sunlight reflecting on a shutter, Aldrin implied a belief that the light was something following and observing them on their journey to the moon. This was not the only reported sighting of aliens around the moon. Alan Bean saw a peculiar pillar of light during the Apollo 12 mission in 1971, and Apollo 15 astronaut James Irwin filmed an object resembling a flying saucer hovering over the moon's surface in 1971. NASA typically dismisses such sightings as optical illusions, dust, or camera reflections, but a growing community believes in alternative explanations. Whistleblowers and witnesses, including those within NASA, claimed that aliens maintain secret bases on the moon. In the 1990s, psychic Ingo Swann, who was asked by the FBI to remote view the moon in the 1970s, published a bestseller describing his unsettling observations of aliens conducting activities on the moon. The question arises, what attracts aliens to the moon? Recent revelations by the Lunar Reconnaissance Orbiter have challenged the perception of the moon as a dry celestial body. Enormous deposits of water ice near the poles suggest the moon may not be as barren as once thought. Lava tunnels on the lunar surface indicate a past geological activity, and the moon's peculiar reverberations after meteorite impacts hint at the possibility of it being hollow or containing numerous caves suitable for habitation. The idea of aliens mining on the moon has been present since the 1950s and 60s, with traces of mining and the outline of a mining vehicle allegedly recognized in moon images. The discovery of helium-3, a rare resource on Earth, further adds to the intrigue. Helium-3 could potentially solve the Earth's energy problems through nuclear fusion. The recent Chinese Chang'e 5 mission to the moon's far side aimed to explore this region, known for its helium-3 deposits. The unresolved questions about why aliens are interested in the moon might be answered by their pursuit of valuable resources, particularly helium-3. The possibility of aliens settling or maintaining a base on the moon arises from the unique features like lava tunnels and water resources. While human missions to exploit these resources are not currently cost-effective, technological advancements may change this in the future. Transient lunar phenomena, such as light rays or ray cones emanating from certain craters, have fascinated astronomers since the invention of telescopes. These phenomena occur regularly, and some skeptics argue that they may not always have a natural origin. Professor Dr. Ingo Hacken-Kyle emphasizes the need to understand the origin of these phenomena before sending humans to the moon for extended periods. Claims that lunar settlements are fake and that NASA discontinued moon missions due to extraterrestrial threats have circulated among UFO researchers and NASA critics. However, NASA's Artemis plans, initiated in 2017 and manifested in the Artemis 1 launch in 2022, contradict these claims. The Artemis project, involving new rockets and spacecraft, suggests a renewed commitment to lunar exploration, challenging speculations about a fake lunar program. In conclusion, the mystery of aliens around the moon involves reported sightings by astronauts, revelations from psychic remote viewers, and ongoing lunar exploration efforts. The moon, once perceived as a dry and lifeless celestial body, now presents intriguing possibilities with water ice, lava tunnels, and the potential for valuable resources like helium-3. The question of aliens' interest in the moon remains open, inviting further exploration and discovery. NASA plans to land astronauts on the moon with the crew of Artemis 3 in May 2024. The landing will be part of an extended mission, but the exact launch date remains uncertain. Additional plans involve collaboration with Elon Musk's SpaceX to send a space capsule to the moon, serving as an exploration vehicle. 2 astronauts are expected to spend 2 weeks exploring the moon's South Pole region. Consider the scenario of traveling at the speed of light aboard a spaceship. While popular in science fiction, the reality of such a journey raises intriguing questions. At the speed of light, what would one see outside the spaceship, and how would the body be affected? Light, which travels at approximately 299,792,458 meters per second, undergoes unique changes when the spaceship accelerates to high speeds. The Doppler effect comes into play as the spaceship moves toward or away from stars. Stars' light shifts towards the red end of the spectrum when moving away, creating a red shift, while moving towards stars causes a blue shift. However, astronauts traveling in space often report the absence of stars in their view. This occurs because space lacks an atmosphere to scatter light, making stars appear dim and barely visible. Another intriguing aspect of high-speed space travel is time dilation, a consequence of Einstein's special theory of relativity. Time passes more slowly for a moving observer, implying that a long journey at high speed would result in less aging for those on board than for people on Earth. This phenomenon raises questions about the nature of time in different parts of the universe and the possibility of controlling or circumventing it. While reaching the speed of light is currently considered impractical, researchers explore the concept of warping space, a notion inspired by science fiction. The idea involves bending space and the spaceship, allowing it to slip through a hole in the space-time structure. This theoretical approach could offer faster-than-light travel, crucial for interstellar exploration. A hypothetical scenario set in the year 2150 envisions spaceships reaching the speed of light. The crew experiences effects such as a sensation of sinking into a deep sleep during acceleration, body shrinking due to time dilation, and gravitational forces leading to muscular atrophy and bone loss. Time becomes disorienting, and upon returning to Earth, the crew discovers that many decades have passed. In conclusion, the challenges and possibilities of space travel, especially at speeds approaching the cosmic limit, open up a realm of scientific inquiry and speculation. The practicality of achieving such speeds, the impact on human bodies, and the mysteries surrounding time continue to captivate the imagination of scientists and enthusiasts alike. Theoretically, it is challenging to reduce an object made of matter to its information, as suggested by quantum mechanics. This information could, in theory, be used to reconstruct the object at a different location. However, the intricate replication of a human being or a spaceship at an atomic level poses the greatest mathematical challenge. Achieving this would demand an enormous amount of data, requiring the capture and reconstruction of the complex structure of a human being at another location. Despite the theoretical potential, biological aspects raise questions about the fate of matter, blood, organs, and the recreation process at the destination. The concept of reconstructing UFOs aligns with the numerous reported sightings that challenge known laws of physics. These unidentified flying objects exhibit movements contradictory to Newtonian physics, with reported dynamics and accelerations that defy explanation. UFOs, often described as flying saucers or objects with unconventional propulsion methods, present a profound mystery. Their ability to navigate space in ways unknown to human technology suggests that there is much to be learned about space travel. Whether aliens will provide insights into building such unconventional spaceships remains an open question. Embarking on a fictional journey through the structures of the universe, starting from Earth and traversing familiar celestial bodies, unveils the vastness and complexity of our galaxy, the Milky Way. Beyond our galaxy, we encounter stars, nebulas, black holes, and witness the birth of stars. The journey extends to other galaxies like Andromeda and the Virgo galaxy cluster, revealing the intricate dance of galaxies influenced by invisible threads of dark matter. The narrative introduces the mysterious dipole repeller, an empty space with significant implications for the accelerated expansion of the universe. Though the exact nature of this structure is still under research, it is believed to play a crucial role in shaping the stability of the universe. The concept of the dipole repeller arose in 2017 when astronomers proposed it as a key contributor to the universe's accelerated expansion. Through studies like the 2-Mass Redshift Survey and the Cosmic Flows 3 catalog, researchers have explored the distribution and movements of galaxies, revealing patterns influenced by structures like the Great Attractor and the dipole repeller. These cosmic structures impact the movement of galaxies, creating complex patterns in the universe. The dipole repeller's mysterious influence on galaxies raises questions about its function and whether there are even larger structures in the universe. The universe's structures, resembling organic entities or even a brain, prompt speculation about the universe being a colossal living being. The mystery surrounding attractors and repellers is compounded by the limitations of current cosmological concepts, as these structures remain unseen. The potential existence of cosmic structures like the dipole repeller presents unsolvable puzzles, emphasizing the profound mysteries that continue to captivate scientific inquiry. The consequences of the Big Bang voids were initially observed by astronomers in the 1970s during their examination of galaxy distribution in the universe. These voids, characterized by the absence or thin distribution of galaxies, include well-known examples like the Bootes void. Researchers now recognize various other voids, with supervoids being the largest, spanning hundreds of millions of light years. The study of voids holds the potential to unravel the mysteries of dark energy and is currently a subject of intense research. Previous investigations into voids have led to peculiar findings, sparking imaginative theories. Some researchers propose that parallel universes may have collided at these voids, suggesting the existence of a multiverse. Additionally, there are intriguing speculations about voids not being empty. Some scientists suggest that advanced civilizations might manipulate these regions to harness energy from galaxies. These hypotheses, although speculative, underscore the complexity of these enormous structures and their capacity to challenge scientific understanding. Dark matter and dark energy, despite being invisible, play crucial roles in cosmological models. Dark matter, which constitutes a significant portion of the universe's mass, exerts gravitational forces influencing visible matter in galaxies and cosmic structures. Dark energy, another mysterious force, contributes to the accelerated expansion of the universe, observable in phenomena like the dipole repeller and voids. Understanding these invisible forces is fundamental to deciphering the cosmic puzzle and gaining insights into the universe's splendor. The Moon, often considered a destination fraught with danger, has witnessed numerous probe crashes, raising concerns about the safety of future human missions. Despite NASA's plans to land humans on the Moon after nearly 45 years, recent probe failures, such as the Russian Luna 25 mission, suggest challenges in contemporary space travel. The success of past lunar missions, like the Apollo flights, sometimes overshadows the close calls and accidents experienced by astronauts, emphasizing the risks involved. Moon landings remain difficult and risky due to factors such as irregular gravity, which varies across the lunar surface. Achieving precision during landings requires careful planning, as exemplified by the Apollo 11 mission's manual navigation after an automatic control system failure. Recent lunar missions like India's Chandrayaan-2 faced challenges, with the lander crashing during its attempted landing. These incidents highlight the Moon's reputation as a hazardous destination for space travelers and underscore the need for precision in planning lunar missions. Uncovered an intricate parallel between the challenges of landing on the Moon and the difficulties faced by future lunar missions. These challenges, considered sources of potential danger, stem from various factors. One critical aspect is the irregular gravity on the Moon, a complex variable that poses difficulties in assessment and prediction, making it a persistent hazard for upcoming Moon missions. Another substantial risk factor is the absence of an atmosphere on the Moon, in stark contrast to Earth's dense atmospheric conditions. Unlike Earth, the Moon lacks air friction, which plays a crucial role in slowing down probes during the landing approach. Consequently, landing probes and spacecraft on the lunar surface necessitate the generation of their own deceleration to achieve a gentle touchdown. This challenge was evident in past missions, such as the Soviet Luna 1959 landing module and the Indian Chandrayaan-2 mission in 2019, both of which encountered difficulties in landing due to issues with the braking mechanism and communications. Communication limitations constitute a third formidable challenge in lunar landings. Communicating with probes on the Moon is complicated by the extended distance and limited line of sight to Earth. Notably, during the Apollo 11 mission in 1969, the command module was positioned in orbit around the Moon, out of direct line of sight with the lander during the landing approach. This required autonomous actions by astronauts on the lunar module due to communication delays, highlighting the necessity for innovative solutions. The potential for communication issues was exemplified in the Soviet Luna 15 mission of 1969, where communication problems led to the loss of the probe during its descent to the lunar surface. Recognizing these challenges, the Indian Chandrayaan-3 mission, launched in 2023, was equipped with a fully automatic landing navigation system to mitigate risks. Despite a successful landing, the mission faced subsequent challenges. with the landing modules unable to be reactivated after entering a dormant state during the lunar night, ultimately freezing in the extreme lunar temperatures. The lunar surface itself presents further complications for successful landings. Marked by craters, rocks, and uneven terrain, the lunar landscape poses potential hazards for probes. Moon rocks, some razor-sharp, and the seemingly puffy moon dust, while appearing inviting, harbor allergenic and sharp particles, adding complexity to landing missions. Additionally, extreme temperature fluctuations on the moon, ranging from approximately -173 degrees Celsius at night to around -127 degrees Celsius in the sun, present a significant challenge for probes' sensitive measuring sensors and camera systems. The alternating 14-day periods of scorching sunlight and freezing darkness across the moon necessitate robust technologies capable of withstanding such harsh conditions. Despite these challenges, successful lunar missions have provided valuable insights into the moon's geology, seismic activity, and potential resources like water ice. The cumulative data collected from these missions serves as a foundation for future lunar exploration, including plans for human missions to the moon, highlighting the ongoing commitment to lunar exploration despite the associated risks and complexities. With natural channels or grooves, this led to a misunderstanding, particularly in English, where canali was misinterpreted as canals, suggesting artificial waterways. This sparked public fascination with the idea of intelligent beings constructing canals on Mars, but it was later clarified that these features were likely optical illusions or natural formations. As technology advanced, later observations revealed Martian features consistent with water erosion. The Mariner and Viking missions in the 1960s and 1970s provided significant data indicating the presence of ancient river valleys, dry riverbeds, and features resembling deltas. These findings strongly suggested that liquid water had once flowed on the Martian surface, shaping its geological features. In recent years, more direct evidence of water ice on Mars has been discovered. The Mars Reconnaissance Orbiter, MRO, and other spacecraft have identified ice deposits beneath the surface, particularly in polar regions. Some regions show signs of subsurface ice, and the Phoenix lander directly observed and confirmed the presence of water ice in the Martian soil. Moreover, discoveries of recurring slope lineae, RSL, dark streaks on Martian slopes, raise the possibility of contemporary liquid water. While the exact nature of these features is still debated, some interpretations suggest the periodic flow of briny water during warmer seasons. This discovery has significant implications for the potential habitability of Mars. The overarching narrative of water on Mars has transitioned from the earlier misinterpretations of artificial canals to a more nuanced understanding of the planet's complex history. Mars, once envisioned as a dry and barren world, is now recognized as having a dynamic past with liquid water playing a crucial role. Understanding the history of water on Mars is vital for various reasons. It informs our exploration strategies, especially in the search for signs of past or present life. The presence of water enhances the likelihood of habitable conditions and raises the intriguing question of whether Mars ever hosted microbial life. Additionally, the utilization of Martian water resources is a consideration for future human exploration and potential colonization. In conclusion, the story of water on Mars is a captivating journey from early misconceptions fueled by optical illusions to contemporary discoveries of ancient river valleys, subsurface ice, and possible recurring liquid water. The evolving understanding of Mars' watery past opens new avenues for scientific inquiry and fuels the imagination about the potential for life beyond Earth. Water vapor despite its thinness. The discovery was groundbreaking, challenging the notion that Mars was completely dry. Subsequent missions, such as the Mars Global Surveyor and the Mars Express Orbiter, confirmed and expanded upon these findings. These spacecraft observed the Martian atmosphere and detected clouds, fog, and even snow. The presence of water vapor in the atmosphere raised questions about its sources and processes. One significant source of water vapor is the polar ice caps. Mars has polar ice caps composed of water and dry ice, frozen carbon dioxide. During the Martian winter, a significant portion of the atmosphere's water vapor freezes onto the polar ice caps. As the seasons change and temperatures rise, this frozen water sublimates back into the atmosphere. Another mechanism involves the release of water vapor from the Martian soil. Mars has a phenomenon known as the diurnal water cycle, where water vapor migrates between the surface and the atmosphere over the course of a day. The process involves the absorption of water vapor by the soil during the cold night, and its release back into the atmosphere as temperatures rise during the day. While these processes contribute to the presence of water vapor, they alone cannot explain the historical presence of liquid water on Mars. The history of water on Mars is closely tied to its geological evolution. The planet's surface bears the scars of ancient river valleys, lake beds, and other features shaped by liquid water. Understanding how Mars transitioned from a potentially habitable world to its current arid state is a crucial scientific endeavor. The search for answers continues with ongoing and upcoming missions to Mars. Rovers like Perseverance are equipped with advanced instruments to study the Martian surface, seeking clues about its past and the possibilities of ancient life. The exploration of Mars not only unveils the mysteries of the red planet, but also provides insights into the broader understanding of planetary evolution and habitability beyond Earth. In conclusion, the detection of water vapor in the Martian atmosphere, dating back to the 1970s Viking missions, challenged preconceptions about Mars as a completely dry planet. Subsequent missions confirmed the presence of water vapor and identified its sources, including the polar ice caps and the Martian soil. The ongoing exploration of Mars aims to unravel the planet's complex history, from its wetter past to its current arid conditions, offering valuable insights into planetary evolution and the potential for life beyond Earth. Mars, often called the Red Planet, exhibits a low level of humidity due to its thin atmosphere. However, scientists have discovered that water vapor on Mars likely originates from ice layers, with small amounts evaporating during regional warming periods. This revelation, indicating active water cycles, challenges the perception of Mars as an entirely dry and inhospitable world. The red color of Mars, attributed to oxidized iron in its rocks, further supports the presence of water. Iron oxidation occurs in the presence of moisture, and the Viking probes in the 1970s provided evidence of chemically bound water in Martian soil minerals. Subsequent missions, including Mars Odyssey and the Mars Reconnaissance Orbiter, as well as the Spirit, Opportunity, and Curiosity rovers, identified high hydrate minerals formed through water-rock interactions. These findings imply that Mars experienced periods of abundant water, suggesting a wetter environment in the past. However, the transition from a water-rich Mars to its current arid state raises questions about what happened over time. Unlike Earth, Mars lacks a protective magnetic field, allowing charged solar particles to erode its atmosphere over billions of years. The MAVEN mission demonstrated the ongoing influence of solar wind on Mars' atmosphere, leading to the gradual loss of gases into space. This atmospheric loss, combined with a diminished greenhouse effect, resulted in a cooling of the planet, intensifying the evaporation and loss of liquid water. Chemical bonding of water in Martian crust minerals further contributed to water loss. Research indicates that 30 to 99% of former surface water is now trapped in these minerals, removed from the Martian water cycle. These processes unfolded several hundred million years ago, transforming Mars into the dry, dusty landscape observed today. Looking ahead, both NASA and SpaceX had ambitious plans to send humans to Mars. Exploration and potential colonization are on the horizon, despite the current inhospitable conditions. While Mars lacks a breathable atmosphere and faces temperature challenges, the discovery of water resources opens up possibilities for sustaining human life. Water, beyond its utility for drinking, holds the promise of being a source for fuel and oxygen on Mars, making future exploration and settlement more feasible. In conclusion, Mars, once considered devoid of water, has revealed more dynamic history. The presence of water vapor, tied to ice layers and mineral-bound water, showcases active water cycles on the red planet. Understanding the transition from a wetter Mars to its current state contributes to ongoing exploration and the vision of human settlement on the Martian surface.